Okay, let's carry on with impact. Chapter 15.4. So in the previous video I spoke a lot about this thing called the coefficient of restitution, and we're going to see now how we derive it and kind of how it's defined. What is the coefficient of restitution? Okay, so why do we need it? Just a reminder again, one reason for the coefficient of restitution is that it allows you to calculate final velocities. Okay, final velocities. So you have the two particles, they interact, they collide, right? They apply deformation impulses, they reach, have the maximum deformation where they have the same velocity. Then they have restitution impulses, and they might separate. Not always, okay, but this is just a kind of an illustration here. And one reason for using the coefficient of restitution is so that you can find the final velocities after impact. Okay, so that's the one reason. The other reason is it allows you to find how much energy is lost during impact. Okay, but we'll get to that in a minute. So, how are we going to how do we define this? Well, the first thing is that we know that in a closed and isolated system, like when two particles collide like this, we know that the impulses cancel out. Both the deformation and the restitution impulses, they're internal to the system, so they cancel out. So we have conservation of momentum. Okay, there's nothing new there. The initial momentum is equal to the final momentum. Okay, then the next thing we can do is we can isolate just one of these particles. Okay, so let's isolate A. Let's just look at A. There's A, there's A, there's A. And we'll consider this to be state 1 in this first derivation. This is state 1 where they're still separated and they're moving toward each other. And state 2, or the final state, will be when they have maximum deformation and they're moving at the same velocity. Okay, state 1, state 2. So how does it move from this state to this state? Well, it starts off of particle A. Remember, we're just looking at particle A. Particle A has an initial momentum. Then, if you isolate just particle A, I'm going to draw it there, it's got minus P delta T. So it's got this deformation impulse, negative because it's being applied to the left-hand side. And then at state 2, it has also a momentum, mass times this velocity here. Okay? So I hope that makes sense. Then we're going to also look at particle A, but from this state to this state. So now this becomes our state 1 for particle A, and this becomes our state 2 for particle A. So the first one is called the deformation phase. From this state over here to maximum deformation, and we're going to look at impulse and momentum applied over that state. Then we will move from this, we'll move through the restitution phase of particle A, and it'll start from this point here and it'll end there. Okay, so its initial momentum is in mass times velocity. Then if we isolate just particle A again, we'll see that it has now it has a restitution impulse, right? That's the restitution impulse. And then it has a final momentum. Initial momentum minus the impulse equals the final momentum. Okay? I hope that's clear, guys. Then the coefficient of restitution is then defined how? It's defined as the ratio of the restitution impulse to the deformation impulse. That is how it is defined. But then what is the restitution impulse? What is the deformation impulse? Here is the restitution impulse. There's the deformation impulse. If you solve for these two, okay, you'll see that the restitution impulse equals, if you solve for this, we'll have MAV minus MAVA2, right? And then that would equal RDT. So if we see that then we have this at the top, and then if we solve for the deformation impulse, we will have PDT is MAV minus it's MAVA1 minus MAV. Okay? And then if we put this in, we will see that the masses will cancel and we'll end up with this. Alright. Okay, so I hope you're not too confused. But the point is, we did this for particle A. We do exactly the same thing for particle B. We calculate the ratio of the restitution impulse to the deformation impulse, and we get this for B, we get this for A. So can you see there are velocities, there are differences in velocities. Then if you eliminate V, you end up with this final thing, which your restitution impulse, coefficient of restitution, I'll get there, is simply, listen to this, it is the difference between the final velocities divided by the difference between the initial velocities. Right? So these are the velocities after impact at the top, the velocity of B minus the velocity of A after impact at state 2. Okay? And these are the velocities of the particles at state 1. Now, I know maybe I've confused you, but just consider this now to be state 1 and this final to be state 2. Okay? Alright, see you in the next video. Cheers.